Okay, hello everyone, and welcome to the talk about building robust Python applications on Databricks. And I'm going to be sharing this on the example of UCX tooling. Basically, what problems did we hit so that you don't have to face those problems yourselves. And here's the standard slide. That's, well, yeah, this is experimental product and don't make your purchase decisions about Databricks. But anyway, let's go on. So I am Serge. I've been using Apache Spark since like 2015, like 0.10, 0.12, 13, and I'm on Databricks since 2019. I've created Databricks Terraform provider, SDK for Python, Java, and Go, and CLI, and I'm driving Databricks Labs full-time. So in this talk, I'm going to be showing you how we built Unity Catalog migrations, the automation for it. And it will roughly fall into 4 sections, like group migration, table migration, and how we migrate the code or how we plan to. Anyway, let's start. UCX is something that you're supposed to install on your local machine. And from your local machine, you are talking to Databricks accounts and multiple workspaces within Databricks accounts, because Unity Catalog is something that spans across multiple Databricks workspaces and it belongs to account level. So it's installed from Databricks CLI and talks to AWS APIs and Azure APIs. And UCX installs all of managed workflows. So we have 4 managed workflows. Assessment workflow, something that tells you of what you have in a workspace that is not compatible with Unity Catalog, like cluster configurations, jobs, DLT pipelines, and so on. After that, we have a workflow for group migration, because Unity Catalog works with account level groups and workspaces have their own groups, and we have to reassign permissions to those. And then we need to migrate tables from local Hive Metastore into the Unity Catalog. And after that, or even during table migration, we have to migrate all of the code. So UCX will help you to either tell what code is wrong and why you need to change it, or even migrate the DB name, table name into catalog name, DB table name. So let's get started. UCX is installed from Databricks CLI, starting from version 210 something. And it launches the Python command line installer process that gathers some basic information about your workspace and helps us to understand better, what do you need to do to perform this Unity Catalog migration. And while installing UCX, you are going through a very simple set of questions and command line interface prompts that I actually built using a Python input function. And this function works the same way for Windows, for macOS, for Linux, meaning this simplest library for installation is the simplest interface that we can actually support with limited resources that we have. And you can see that we can even do some drop downs. We can do the input prompts, default values, confirmation buttons. We exposed it as a separate library for you so that if you need to do a very simple command line interfaces that need no external dependencies, use that. So please open up your phones and take a picture of this QR code so that you are redirected to a GitHub page showing the documentation of UCX. Essentially, it will show a very big and nice README of everything that this code base is doing, and you'll be using it a lot to migrate to Unity Catalog if you didn't do that yet. Or you can look through the code as we speak. Everyone took a picture? Awesome, I hope so. So essentially, the code base has been actually growing for a while. We started this approximately a year ago. And at the moment, it approaches 70,000 lines of code. And we've invested roughly 10,000 hours into it. And basically, 70,000 lines of code in this code base, and then approximately 50,000 lines of code in other supporting code bases is not a small project. So in order to manage this not a small project, there needs to be certain techniques required to make sure it doesn't fall apart, make sure that it works, make sure that many people can still use it. So let's talk about that. So the first workflow I'm going to mention here is about group migration. So what is it? You know that in order to migrate groups from workspace level into the account level, We need to collect permissions from legacy table locals, from permissions of clusters, instance pools, and get secret scope permissions, and redash permissions, and skim entitlements. Then, after we collected all permissions, we have to rename all the workspace level groups to a temporary prefix, then add account level groups to the workspace, and assign all permissions that previously belonged to the corresponding workspace level groups with the same name. And after that, we remove the previous workspace level group from that. Sounds quite complicated because there are a lot of moving parts, and we had many challenges with this, like calling APIs, logging, and error recovery. So let's dive in. Direct API integration is hard because Databricks has many different API styles and has 7 different kinds of pagination and 7 different formats of identifiers. And you need to use Databricks SDK for Python or any other languages to save months of effort. Because it would have been simply impossible to build UCX without Databricks SDK for Python, and it literally saved us months of effort. What is one of the most important things about Databricks SDKs is that it has a feature that is called Unified Client Authentication that allows you to have a zero configuration workspace client that works on your development environment. When you authenticate with Databricks Auth-Login CLI or AZ-Login CLI, or on production, you authenticate with just a set of environment variables, either for Azure Service Principal Auth, for OADC Auth, for Google Auth, or other things. And this saves a lot of effort because we'll literally use the same code, like from Databricks SDK import workspace client, then we initialize that workspace client, and it works out of the box without having to configure anything because all of the tokens are picked up from the environment variables or from CLIs, and we don't have to check in any sensitive information to code at all. This is great. So make sure to use Databricks SDK for Python for any automation that you are doing with your work. Don't call RESTful APIs directly. Call them through Databricks SDK for Python because we support latest, greatest features in there, and it's regenerated every 2 weeks. It's great. It's awesome. Now, one of the features that we have within Databricks SDK is that we have a robust error hierarchy. What does it mean? Well, it means that every HTTP error code is having corresponding exception class. And whenever some errors are happening inside of the Databricks platform, we can catch them as exception messages. And all of the errors are in the hierarchy. So for example, if you want to recover from any Databricks errors, you just catch Databricks error. If you want to recover from any resource conflicts, you just catch the resource conflict error. If you want to recover only from a very specific exception, like operation was aborted, which is also a resource conflict, you accept the aborted. Now, why does it even matter? Well, if you build real applications that call a lot of APIs, you may have noticed that some of the APIs in the Databricks platform are eventually consistent. And how do you save yourself from that? Well, you retry. But what do you do for retrying? Do you retry everything? Well, not quite. Databricks SDK has a very nice decorator called retried that can allow you to retry only on a couple of exception types that are thrown. And in this example, for example, if we try to delete a group, there might be internal error happening. There might be deadline exceeded error happening. And there might be not found error happening. So when not found error is thrown, we just don't retry because we've deleted the group. And if we try to delete it again with the delete commands, we don't need to repeat that because we know that group is no longer there. And whenever we see internal errors or deadline exceeded errors, we retry for a timeout of period of time. And this is quite similar, actually, to how Terraform works in general internally. Because inside of Terraform, there is a pattern of behavior called create, read, read. Like we first create the entity, then we get back the ID of that entity, then we read that entity again, and then we read that entity again. And then we compare the data coming in from the first read and the second read. And if first read and second read data does not match, we have to wait for a bit for these things to match together. And if that operation times out, we kill the application because platform is in the inconsistent state. So create, read, read is, for example, a technique that we're using in group migration to verify that permissions have been migrated correctly and the state of the system is consistent. So, and the same pattern might be applied in other applications. So remember, create, read, read is the pattern that you need to use in order to make sure that you are protected from eventually consistent behaviors. Then, as you may know, how many of you did program in Golang? Oh yeah, I see quite a few hands, which is great. So essentially, robust Python application code really looks like a Golang code, where you check error with every operation, and then you know, okay, this operation we're handling this error, that operation we're handling that error, and Python code starts looking pretty much like Go. Like, you know, when you are building production applications, most of the time is spent operating them rather than constructing the code itself. And logging is very, very, very important. So here's a typical log-intensive workflow in Databricks. In the first minutes, you see all the logs. After 5 minutes, you see logs from the first minute and logs from the 5th minute. You don't see the logs from the 3rd and 4th and 2nd minutes. And this is exaggerated when the workflow is running for 2 hours, 5 hours, 40 hours. You see only the first minute and last minute of the logs. So how to deal with this? Well, quite simple. You either add centralized logging solution like Elasticsearch Log/Kibana Stack or Splunk, or you are logging every minute to a Workspace file system with time-rotating file handler. Why do you need to do that? Well, first of all, Workspace FS makes file available on the browser only after the file handler is closed. So there is no tail. Tail is impossible. If you are used to working with logs like tail, -f, whatever, it won't work with Databricks Workspace FS. The files will be available only after the file handler is closed. And the way to get that is to log every minute with time-rotating file handler. This code is very simple. We'll probably publish some utility to help with that. But yeah, this is the nerdy piece of this presentation, code snippets. So log every minute if you don't have the centralized logging solution, because that way you will be able to go to the Workspace FS, to the Workspace browser, and view the logs and debug your application to know what was happening during your production job. In UCX, we are taking it even a step further because we have machine-readable names of jobs. And for every job run, we are creating a folder where every task has a log file per every minute of execution. And in UCX, we have a command called logs that parses those logs. So keep in mind, if you need a robust example on how to deal with logging from Databricks workflows, take a look at the UCX codebase because I think we are doing it quite well there. Now, let's talk about another workflow and the challenges of it. We have table migration. And table migration workflow is involved because first we need to scan all of the tables within Hive Metastore. That takes usually 15 minutes on workspaces with 500,000 tables. Then we need to scan all of the mounts to figure out what were the actual sources of those tables, if they're external tables. Then we are scanning the permissions on the cloud provider to know, like, hey, what Amazon IAM policies exist for these tables, what service principals have access to that storage account in Azure. And then we are asking the user the following question. Hey, here is the CSV file for all of the tables that we've detected in your workspace. Please take that CSV file, upload it to Excel or Google Sheets, and spend the day figuring out, is this going to be your destination Unity catalog schema or not? Because usually you see migrations are done with the data governance console, where some tables and databases are shuffled between different catalogs. I mean, sure, we want to enable that to make it better, but CSV is the only way that is editable through Workspace UI, in a way. And we don't really have a CSV editing capabilities beyond text. So yeah, that's good enough. And then after processing the CSV file, we are allowing customers to create the storage credentials and external locations in UC by calling the Amazon APIs and Azure APIs and automating it all. And once the storage credentials and roles and locations are created, we proceed to executing 500,000 sync table statements for external tables, or proceeding with things like deep cloning Delta tables, or converting non-Delta tables to Delta tables while migrating this, and keeping the track of this whole migration state and successes of it all. Well, as you imagine, it is quite a complicated operation set, and we need to observe it. So we have challenges. Dashboards. Obviously, we need to have integration tests for it all. And during integration tests for it all, we have to actually deal with unreleased wheels. Well, dashboards. In UCX, we are managing approximately 7 or 8 different dashboards from code. And how we deal with it? We have a SQL file per widget, and a SQL file is turned into a widget by our framework that creates dashboards. We are now working on creating Lakeview dashboards from code, because currently UCX uses redash dashboards from codes, and they are a bit slow to deploy. It takes like 40 seconds to create a dashboard with 50 widgets. With Lakeview, it's roughly 3 seconds. So essentially, there will be the open source library that you'll be able also to use in the same way as UCX does to manage your dashboards as code, so that you have a bunch of SQL files annotated with some metadata in the top of the file, and let the library or command line tool create the dashboard from code, because it's quite complicated and it's quite common thing for either us application developers or for analysts to version control dashboards. So that's one of the things we've solved in relatively okay way, I think. Then the other thing that we solved with regards to SQL management is what I call a SQL execution backend. So in UCX, we try to limit our interaction with Databricks through SQL only. It allows us to use SQL execution API when we invoke UCX from command line. It allows us to use Spark as SQL backends when we execute in Databricks Workflow. And it allows us to use mock backends when we execute queries through unit tests, so that all of the backends are swappable and our unit tests execute under a minute. So if we limit our interactions with data only through SQL, it's simpler. And we currently have 4 SQL execution backends, like statement execution backend, which is recommended only for things like small scripts, command line applications, or things like Lambda functions. Then Spark SQL backend, and Databricks Connect backends, and mock backend for testing. So take a look at this lightweight SQL execution wrapper through this QR code. it may get useful for you. This project would also have dashboards as code eventually. Like we are working on it now, and once we migrate UCX to Lakeview dashboards, then it would be documented on the README of this project. Another thing, and very fun thing, is about finding hidden bugs with Pylint and MyPy and RAF and other things. So, how many of you are using Airflow? Yay, awesome. How many of you did you migrate to Unity Catalog with Airflow? Not many. So for those who did not migrate to Unity Catalog with Airflow, know that if you don't specify data security mode explicitly in your Airflow tasks and you enable Unity Catalog on a workspace, your jobs will break. And this is a very unpleasant thing. So to prevent this unpleasant thing from happening, we have created a Databricks plugin for Pylint. That's please take a look at it and start using it, because it's as one of the features of Pylint plugin for Databricks. We scan the code of Airflow DAGs and check if there is no data security mode specified for Databricks operators, and throw you a warning. For Airflow, we also, besides Airflow, we have 20 other checks, like if you have a legacy CLI used in your notebooks, or if you're using internal APIs, or if you have a leaked pet token inside of your Python code, or if your Spark code is not so testable, or if your notebook has more than 70 cells, which is unreasonable, etc., etc., etc. So this Pylint plugin has approximately 20 checks, and they are all right, and sometimes we add more. And of course, open source contributions are welcome. So it's GitHub. Please make a fork and make a pull request. We'll be happy to get those features in and start using Pylint. But how many of you are using Pylint? 3 or 4. How many of you are using RAF? How many of you are using Flakes or PyFlake? Okay, so there are a couple of tools for static code analysis in Python, and some people just ask why you don't just use a tool that's called RAF that works 10 times faster than Pylint. And my answer to that is usually that RAF is great. It works 10 times faster than Pylint, but it's not extensible at the moment. You cannot write a plugin for it at the moment. And for UCX, we're using Pylint, MyPy, and RAF in combination. And that works pretty well, because just MyPy won't cut it. Just RAF won't cut it. But combination of Pylint, MyPy, and RAF is the best of all worlds, and it will get you proper protection from hidden bugs in your code. When you start adopting those tools, you'll be a bit annoyed by all of the warnings. But yeah, that's life. Life is not to make you happy. So yeah, use Pylint plugin for Databricks because it simplifies your life. And now, to simplify your life even further, you probably want to structure your application the way that singletons of your main objects are easily swappable. So there is a software design pattern that's called singleton. But if you are having methods called instance, you're doing it wrong. Because if you have method instance or something like that, you're doing it completely wrong. Because you cannot swap the instance in the scenario where you run a unit test in parallel. So the best way to do it is through so-called context factories, or just factories. And the whole singleton framework is comprised of a decorator, functools, cache property, and a method called replace that just replaces the instances of the singleton inside of the instance. So UCX has roughly 250 singletons that sometimes depend on each other. You see this very complicated web on the right of the slide. And in unit test, for example, we replace SQL backend that's in the top of that web. So that's unit tests work with smaller versions of objects that don't even talk to the real backends. And this refactoring to cache properties helped us to make our code base very robust. Like, bottom line, if you have a lot of singletons or not, start using the classes with cache properties and create all singletons through methods decorated with cache properties. And when you depend on other singletons, call them through these properties. That way, you'll be sure that things are initialized only once. So there were many techniques and alternatives possible. Like initially, so I'm coming from Java myself, and I thought, hey, let's actually write a bean annotation from, so we have the equivalent of Spring Boot. But creating custom decorator in Python would not get you a very nice auto-completion in PyCharm and VS Code. And it would not be friendly with PyLint and MyPy. And it would not work as expected. So I tried extending add property decorator. It didn't work as expected. I tried to replicate the behavior of add property. It didn't work as expected. I tried to have combinations with functools cache and property in various different sequences, and it didn't work as I expected. And Jason Grout from the Jupyter project actually suggested the cache property, and this is exactly what we want. If we are coming from Java, the equivalent of bean annotation. Now, let's talk about integration testing. So it's actually quite fun because we run all tests in parallel, and we retry individual tests until a timeout if they fail. And as you imagine, that integration tests can have a lot of flakes, meaning false positives. So how do we deal with false positives? We run all tests in parallel, and things that fail, we just run again, but in sequence. So there are less chances to interfere with things. And then we analyze the tests that fail the most often, and so we try to make them more robust. And we have quite good integration with GitHub Actions. So essentially for every pull request, we run a set of integration tests with the real Databricks account, with the real Databricks account administrator privileges. And we run it through GitHub OpenID Connect so that we don't have to store any secrets anywhere that we have to rotate every 30 days, which is great. GitHub and Azure, very good collaboration in there. And every time the integration testing suite has finished running, we comment on the pull request. And then every night, like every 7 a.m. in the morning, we also run all tests, but for all failures that we could not recover from, we're actually creating real bugs. Because if tests are failing every night, then meaning something is wrong and it will fail at the customer, actually. So what's the takeaway from for you? Well, run integration tests on every pull request if you can afford that, and also run it out of bands every night because you'll get a bit better stability in terms of results that you can analyze. Like we're using PyTest. It's the greatest framework. I mean, it's not in standard library, but it has one very great feature, and that's called PyTest fixtures. So PyTest fixtures allow us to create micro environments. So for example, UCX has a few hundred integration tests, which means that we test a few hundred different micro installations of UCX every pull request. And then we clean those micro installations up after the test has finished executing. But if there was a seg fault or other thing, we use some other mechanisms. But anyway, PyTest is a framework that has this concept of fixtures that are very great and simple, because it enables us to debug those integration tests quite efficiently. For example, like in order to test something, you need to create a database, a couple of external tables, and a couple of service principals. And those service principals have to be configured in 20 different ways for 20 different of your tests. And you want to make those configurations quite reusable, and you want to make a cleanup of those things quite reusable. And only with PyTest, we can actually do this quite efficiently. And yeah, you're looking, hey, you're debugging, and you're seeing the real Databricks Workspace client in, and you're connecting to a real workspace. And you didn't have to change any code. Well, it works, this magic relies on a pattern I've introduced 5 years ago to our multi-cloud testing framework that has one paradigm called get from environment variable or skip executing this test. So with this technique, if we have end or skip idioms inside of tests, we can check if a current test is running from a debug mode. And if it's running from a debug mode, then we load environment variables from a special file. And the developer might be having multiple versions of that special file, so that they pick up and work with that environment. Because basically we test UCX on Azure, we test UCX on Amazon Workspaces, and we test it on workspaces with different configurations. So that's why we have different environments. And this env or skip allows us to keep our test code multi-cloud and don't have too much logic. And this actually scales and works because the same technique is used to integration test Terraform provider, Databricks CLI, Databricks VS Code extension, Databricks SDK for Python, Go, and Java, UCX, and other things. So, like you're talking about fixtures, but there are really two kinds of fixtures. There are static fixtures that are created by Terraform, and there are dynamic fixtures that require cleanup. So sometimes I've seen customers doing strange things. So those stranger things were like provision Azure Databricks Workspace with Terraform and a couple of clusters inside of it and wait for 25 minutes for it to happen, just to run one Databricks job that runs for 75 seconds and then shut everything down. Well, that's a very strange thing. Don't do that. Have static fixtures that you pass down to your integration tests through environment variables, and then have dynamic fixtures created by PyTest. And whenever you have tests that's kind of crash for some reason as the process, like segfault or out of memory or something else, we have another project inside of Databricks Labs that's called Watchdog, which essentially removes everything like users, clusters, notebooks, whatever that is not created and managed by Terraform. We're like probably gonna make it public, but I don't know when. We just don't have time. But the idea is that Watchdog just nukes everything within the workspace, and it also introduces the elements of the chaos testing into our integration testing suite. Because imagine, like at the edge of the hour, Watchdog runs and it removes jobs and users. And then integration testing suite is running at the same time, and it crashes, telling, oh yeah, I've created a job, but then the second after, something deleted the job. What is happening? And essentially, this chaos testing helps us to make our applications more robust because it uncovers the external influence bugs. And think about it. And if you want to discuss early access to this thing, if you have use cases to clean up your workspaces from something that is not managed by Terraform, then yeah, drop by. Let's discuss that. Now, I want to briefly go over a beautiful tooling that I call Databricks Labs Blueprint. So it is a set of libraries that's are focused on production usages. So for example, you often need to deploy wheels. But how many of you have private PyPy registries? Oh yeah, so this is for you because like you want to run integration tests with unreleased version of that wheel, and often it's a big pain in the neck to deploy that unreleased version of a wheel to your private registry. And with these utilities, you can actually upload the unreleased version of a wheel to Databricks Workspace FS and use it within your job to like verify, oh yeah, okay, is my Databricks job working well and working fine? And it handles all of the wheel building, it handles all of the version bumping, because you have to actually configure the version file inside. So there will be a QR code about Blueprint. So if you need to test unreleased versions of wheels without putting stuff to your private PyPy registry, yes, this is the way to go. The other utility is about configuration evolution. So how many of you that have to change the formats of your, JSON file or YAML file where you store your configuration for your app? I see a few arms. Okay, how many of you use? But there are really a couple of ways how you manage configuration for your jobs. It's either Spark Conf through clusters and jobs, or some file like YAML file or JSON file or TOML file or something else. But you sometimes find yourself in a need that you need to rename a field or you need to remove a field. And these things are complicated, actually. So in Terraform, inside, there is a concept of state upgraders that takes a dictionary, converts the dictionary into another shape, and saves that into a file. This is the same thing. It allows you to manage installations and manage the files of installation and evolve the configuration format in there. How many of you that face a challenge that you have to automatically add a column to a database or reconfigure something in Databricks every time you deploy to production? Yeah, this is it. This is a database migration framework. Essentially, Blueprint upgrader framework allows you to run a set of scripts once per deployed version of the application. Essentially, there is a set of scripts that has this function upgrade that takes a Workspace client and current installation object and executes it if it was not executed on that Workspace before. So whenever you need to have unattended update of your database schema, use it for these purposes. Then we are having some simplified utilities for parallel execution with threads or concurrent. I don't care. It's usually hard. And with this, it's a bit easier because we have a bit better error handling here. So open up your phones and start trying out the Databricks Labs Blueprint because it has these and a few other production-focused utilities that make your life easier. Then the other major workflow I want to briefly touch is code migration. Because during code migration, we really want to analyze like 10 million notebooks and answer a couple of questions and give answers to customers to a couple of questions, like what tables were migrated where, and what is not compatible with Unity catalog in this SQL code or in this Python code. And later, try to do best effort on replacing DB table into catalog DB table inside of your Python notebooks, Python code, and SQL code. We already do that, by the way, for Redash dashboards. So if you used UCX to migrate to Unity Catalog and all of your tables are external, we already are able to migrate your views and your Redash queries because we just replaced the table names that were migrated. And how do we do that? Like, we really analyze the code, we build fully fledged parser, and we tell, hey, you're using RDD. You cannot have that in Unity Catalog. Hey, using DBFS directly. DBFS would not really work with Unity Catalog because DBFS is workspace only and has no ACLs. Don't use that. Or, hey, you are using the table that is already migrated to Unity Catalog. Replace the usage. And so we are building hundreds of checks like this into UCX to give you exact pinpointed problem highlights so that you can migrate faster. And for migrated table replacements, we will try to migrate that code automatically. I mean, that will come later. For now, we're focusing on linting and making sure it makes less noise than it makes now, because we released it literally 3 weeks ago, and it has a lot of bugs for now, but please start using it and checking the notebooks and your Python libraries to see how compatible they are with Unity Catalog and report bugs. Because, like, really, how it works. We have notebook sources, and we use Asteroid library to analyze Python abstract syntax trees, and SQLglot to analyze SQL queries. And then we generate alerts, and later we will do code modification suggestions. We'll try to expose that information in a nice way to you, either as dashboard or perhaps as hints within notebooks. But stay tuned. It takes a while to get those things in, and we may or may not be able to do that. So stay tuned with the announcements for UCX. But yeah, I want to say thank you. Please, connect on LinkedIn, GitHub, or blog or something. That's me, linkedin.com/Martin, or Twitter or GitHub. And please use Events app and tell us what you think. And yeah, thank you for attending this session instead of going to drinks.